Welcome to the Explainer. Today we are going to crack a secret code, one that's hidden in plain sight. It's the mathematical language behind one of the most common shapes you see in the world, the parabola.
So you see this curve, right? It's a parabola. And you've seen them literally everywhere, from the path of a basketball shot to the shape of a satellite dish. But how do we actually tell its story using math? How do we find its unique equation?
Well, the answer is this really powerful tool, a kind of secret code called factored form. And over the next few minutes, we're going to crack it together. We're going to learn exactly how to read it and how to write it.
Okay, so this is it. This is our code. That a is just a value that controls the shape, but x1 and x2, those are the two most important clues a parabola can give us, the exact spots where it crosses that horizontal x-axis.
All right, let's dive right in. We're going to be like mathematical detectives for a minute and build a parabola's equation using only the clues we can see on its graph. It's really just a simple four-step recipe. First, we find our main ingredients, the intercepts. Then we plug them into the formula. After that, we use one more clue to get the proportions just right. And finally, we write out our final creation. Let's do it.
Okay, step one. We just look at the graph and spot where that curve crosses the x-axis. And you can see right here, it happens at -2 and at +3. These are our primary clues. This is our x1 and our x2.
Now, we just plug those numbers directly into our factored form. And this is super important. Notice how the signs flip. X minus a -2 becomes x plus 2, while x minus 3 just stays x minus 3. And just like that, we've built the skeleton of our equation.
But every skeleton needs its own unique shape, right? That's where a comes in. A is the magic variable. It's what tells us if the parabola is going to open up or down, and whether it's going to be skinny or wide. To find it, we just need one more clue. Any other point on the curve will do. Let's use this one, the point 0,6, and just plug those values in for x and y.
So we just do a little bit of quick algebra here. 2 times -3 is -6. Divide both sides by -6, and there's our answer. The secret sauce, our a value, is -1. And that negative sign is a huge clue. It tells us the parabola opens downwards.
And for our grand finale, the last step, we just put that a value back into the skeleton equation we made earlier. And there you have it. We've successfully taken a picture and turned it into its own precise mathematical story.
So that was one way. But what if we try this in reverse? What if we start with the code and want to create the picture?
All right, check this out. We've got a new equation. This time, all the clues are already packed inside. Our job is to pull them out, one by one, so we can understand the exact shape and position of the parabola it's describing.
So, where do you think we should start? Well, with factored form, the most obvious clues are always staring you right in the face. What are the points where this graph is going to hit that x-axis? They're hiding in plain sight. You just got to remember to flip those signs again. The x plus 4 part gives us an intercept at -4. The x minus 2 gives us one at +2. See? So easy. Boom. First 2 points, found. Okay, so every single parabola has this perfect center line, a line of symmetry, kind of like a mirror line, where one side perfectly reflects the other. So where is it for our equation? And the really cool part, it's always smack dab in the middle of those two x-intercepts we just found. So the midpoint between -4 and +2 is the line x equals -1. That's our center line. All right, now for the main event, the most important point on any parabola, the vertex. This is either the lowest point if it opens up, or the highest point if it opens down. It's the absolute peak, or the valley. So where is it? Well, think about it. We know the vertex has to be somewhere on that center line we just found, right? So we take that x value, -1, and we plug it back into our original equation. The output we get is the y-coordinate. So our vertex is at the point -1, -9/2. Now here's something really interesting. Factored form isn't the only way to write this equation. You should think of it as just one dialect in the language of parabolas. Let's see how it connects to another really common form. See, if you just multiply out all the pieces of a factored form equation, you get what's called standard form. They look totally different, right? But they describe the exact same curve. They're just two ways of telling the same mathematical story. Okay, so we've gone from the picture to the code, and from the code back to the picture. Let's wrap up. What are the key tools you should really have in your back pocket now?
So here's the bottom line. Factored form is all about those x-intercepts. That a value is what fine-tunes the shape. And most importantly, you got to remember this is a two-way street. You now have the skills to look at a graph and write its story, or to look at an equation and draw its picture.
So you did it. You've cracked the parabola's code. And this isn't just about solving a math problem, it's about learning a language that you can use to describe the world. So the real question is, what else out there is just waiting for you to find its secret code?